Hello, this packet is going to be the packet on subtracting fractions. So what will you learn? We are going to take a look. So in this packet, you're going to be able to understand how to subtract fractions with the same denominators, how to subtract fractions with different denominators, how to subtract mixed numbers, that's where you have a whole number and a fraction together, how to borrow when subtracting fractions with mixed numbers, and how to apply your subtraction skills with word problems. So let's get started. I'm going to bring up the packet. If you need to pause the video at any time to get the packet or to get something written down, feel free to do that, or to rewind it, whatever you need to do. This is the subtracting fractions with the same denominators packet. And we're going to try some different problems. I'd like to start with some of the information here you can read through. I'm going to just go right into teaching and the practical use of some of these things. So let's put myself down here. So looking at the first one, we're going to subtract the fractions. So the first one I want to do is this one right here, 5/9 minus 2/9. So what I'm going to do here is I'm going to make a little bit of white space so that we don't have to worry about looking at too much stuff at once. Okay, 5/9 minus 2/9. I first ask myself, are the denominators the same? And yes, the denominators, the bottom numbers are the same. They're both 9. So I don't have to worry about changing them to get them to be the same denominator. They already are. So I just subtract the tops. 5 minus 2. The numerator is subtracted. 5 minus 2 gives me 3. And my bottom stays a 9. Just like addition with fractions, your bottom number will remain what the denominators are. So 3/9 is my answer. However, you now know that most of the time you're going to have to reduce your fractions. So I know that I can divide the top and the bottom by the top and the bottom by 3, right? 3 will go into both 3, and 3 will also go into 9. So 9 divided by 3 and 3 divided by 3. And that will give me 3 divided by 3 is 1. 9 divided by 3 is 3. So the answer to number 1 there is 1/3. Let's take a look at the last one in row 2. So clear my screen here. The last one in row 2 here. And again, we're going to put some white space there so we can just take a look at what we want to look at. In this case now, I just want that one. Okay. So we have 17/20 minus 13/20. First thing I ask myself, are the bottom numbers the same? And yes, they're both 20, so I don't have to worry about changing those to become a common denominator. So I just do 17 minus 13, 7 minus 3, 4, and 1 minus 1 is 0, so just 4 on top and 20 on the bottom. Ask yourself, are you finished, or is there more to do? Of course, there's going to be reducing. So we can divide the top and the bottom by 4. So divide the top by 4 and divide the bottom by 4, and you get equals 4 divided by 4 is 1, and 20 divided by 4 is 5. So the answer to this problem is 1/5. Okay, let's move on a little bit here. Let's go on to page 32, row 1. Right here, subtracting fractions with different denominators. So I'll put myself back in this corner. So starting with subtracting, we first ask ourselves, and I'm going to also make a little bit of white space again. We're going to ask ourselves, are the bottom numbers the same? And the answer this time is no, they are not the same, they are different. So we have to get a common denominator just like you did when you were adding fractions. So we have a 4 and we have a 2. So I know that 2 times 2 will give me 4. So we can use 4 as our bottom number. And that allows me to keep the 3/4 just the way it is. So I'm just going to rewrite it as 3/4, just so that I keep everything lined up. And I got to squeeze a number in there. Okay, what 1/2 is equal to? Yes, 2/4. So now I have 3/4 minus 2/4. Hopefully you can see that it's all squeezed in there. So 3/4 minus 2/4 is, just subtract the numerators. 3 minus 2 is 1, and then you're left with 4. So the answer is 1/4 on that one. Let's look at the one on the end here, 1/2 and 3/10. So now I have 2 will go into 10, so I can change my 1/2 over to tenths, right? If I was to do that, 2 times what gives me 10? 5. So I multiply 5 on top. 5 times 1 is 5. 1/2 is 5/10. Half of 10 is 5, so 5/10. And I'm just going to rewrite my 3/10 underneath like that. So 5/10 minus 3/10 is 2/10. Am I done? Or do I have more to do? Yes, I have to reduce. I have to divide the top and the bottom, and I'll show that. Divide the top and the bottom by, the biggest I can divide them by is 2, right? So divide by 2 here like this, and change this over. 2 divided by 2 is equal to 1. 10 divided by 2 is equal to 5, 1/5. So my answer is 1/5. Okay, if you need to pause the video to get this down or rewatch it, feel free to do that. I'm going to move on to row 4. Let's do a couple harder ones here. Move on to row 4. So this is going to be with all the extra stuff there. Let's take a look at the first one. We have 13 4/7 minus 7 3/8. So we have now a mixed number, so we have to still subtract the fractions first. Just like when you have whole numbers, you subtract the ones digits first, and then the tens, and then the hundreds, and then the thousands. With fractions, you subtract the fractions first, and then the whole numbers. So we have 4/7, and we have 3/8. So first I have to get a common denominator. So we have to make an equivalent fraction for these. Well, I know that 7 and 8, 7's not going to divide into 8 evenly, 8's not going to work with 7. So the least common denominator that I can come up with in this case is 7 times 8, or 56. 7s are one of those prime numbers that not a lot works with. Okay, so 7 into 56, how many 7s? 7 times what gives me 56? Well, we just said 8. So I times 8 on the top. 4 times 8 is 32. The second one, I have 56 on the bottom. And how many 8s go into 56? 8 times 7. So 3 times 7 on the top is 21. And now I can subtract my fractions. 32 minus 21. 2 minus 1 is 1. 3 minus 2 is 1. So 11 on the top and 56 on the bottom. And can I reduce 11/56 at all? No. So that is as far as I can go on that. Now I do the whole numbers. 13 minus 7. Well, 13 minus 7 is 6. So 6 and 11/56 is the answer. You see how they get progressively more difficult as we go. Let's try the one on the end here. 20 and 9/11 minus 8 and 2/3. So first we have to have the same bottom number. What number would you pick? What's the least common denominator? Yep, 33. You have to multiply the 11 times the 3. That's the only thing that's going to work. I'm going to try to crunch that in here like this. And leave a little bit of room here for the top number. So we ask ourselves on the top, 11 times what gave me 33? Times 3. So I'm going to times 3 on the top. So 9 times 3 is 27. And on the bottom, I have 3 times something gave me 33. 3 times 11, so I'm going to times 11 with a 2. 2 times 11 is 22. And now I'm ready to subtract. So 27 minus 22. 7 from 2 is 5. 2 from 2 is nothing, so it's just 5 on the top and 33 on the bottom. And notice that we can't reduce that any further. And now we just subtract the whole numbers. 20 minus 8. Well, you have to cross this off and borrow and make that a 1, and this would become 10. 10 minus 8 is 2. 1 minus nothing is 1. So the answer is 12 and 5/33. I'm going to clear my drawings. Let's go on to page 33. Number row 14. So these are all very similar problems. It's all doing the same thing. They're just written horizontally. You have to rewrite them vertically in order to solve them for the most part. So let's go on to some of the hard ones here. Let's look at 14. We have 21 and 4/15 minus 18 and 7/10. I think what I'll do is make some white space and make this one real big for us. So let's just get rid of all this excess right here. And a little bit of excess over here. And a little bit over here. Okay, so this is the problem we're going to work on. So I'm going to rewrite it. 21 and 14/15, like that. And I'm going to subtract 18 and 7/10. So I like to write this vertically. It's the best way to solve these kind of problems. 18 and 7/10. And this is a subtraction problem. So first I'm going to subtract the fractions. The bottom numbers, I ask myself, are they the same? No. So we have to get them the same. Well, what do I notice about this? What will work with 15 and 10? I could multiply 15 times 10 and use 150 if I wanted, but that's a pretty big number and I'm going to have to be reducing at the end. So if I can tell that 30 will work, I could use 30. If I don't, no big deal, just use the bigger number. Use the 150 and reduce at the end. So I'm going to use 30 for both. And change colors here. 15 times what gives me 30? Yes, 15 times 2 gives me 30. So if I times 2 on the bottom, I'm going to times 2 on the top. So 14 times 2 is 20. Oops, I want to use the other color now. 28. 28. And then on the bottom, 10 times what gave me 30? 10 times 3. Times 3. And I have to do times 3 on the top. So 7 times 3. Change back colors is 21. So now I subtract 28 minus 21. 8 minus 1 is 7. 2 minus 2 is 0. I get 7/30. And that's as small as it can go. And then 21 minus 18. I'm going to cross off my 2 and it becomes a 1. This becomes 11. 11 minus 8 is 3. 1 minus 1 is 1. So the answer then is 3 and 7/30. Okay. In my drawings, let's go on to page 35. Borrowing. Okay, this is where a lot of people get stumped up. So let's work on this for a little bit. So let's look at row 1, 2 problems. Let's pull our white space up here and cover up the other stuff we don't need. Okay. So we're going to take the first one, 8 minus 5/6, right here. So if I take a look at that, I have to first start with the fractions. So I have to take 5/6, but I have to subtract it from what? Nothing, right? There's nothing there to subtract it from. So I have to go over to the whole numbers and I have to borrow. I'm going to cross off the 7, and the 8, and I'm going to make it a 7. And then I'm going to bring 1 over. I'm just going to put it over here for the moment. I'm going to have to bring the 1 that I borrowed over to the fraction side. But I don't want to leave it written as a 1 because that's not going to help me as much. So I'm going to rewrite 1 in fraction terms. So remember, any number over itself is 1. So 10 over 10 is 1, 20 over 20 is 1, 6 over 6 is 1. So since I have a 6 on my bottom in my denominator, I'm going to make 1 6 over 6. Okay? So now I can rewrite that 6 over 6 right here because I borrowed it and brought it over to the column with the fractions. So now I have enough to subtract from. So I have 6 6 minus 5 6. That will give me 1 6. And then I subtract the whole numbers. 7 minus nothing is 7. So 7 and 1 6. Let's try another one. Let's try the end problem over here. 10 minus 8 elevenths. So let's take a look at it. I cannot take 8 elevenths from nothing because there's no fraction there. So I have to borrow from my 10 and make it a 9. And I'm going to bring over a 1, right? The 1 is going to come over here, right here. But I'm not going to leave it a 1. I'm going to rewrite it, so to speak, rename it. What would I rename it? What would be a good choice? Well, what's my bottom number? My bottom number is an 11, so I'm going to rewrite my 1 as 11 over 11. So now I can rewrite that over here, 11 over 11. And now I subtract 11 elevenths minus 8 elevenths. So that's 3 elevenths. And then I have 9 minus nothing, that's just 9, right? So 9 and 3 elevenths. We're getting the hang of that? Okay, good. We're going to add the next step in there. Clearing my drawings. Let's look at row 3. See what's going to start happening here. And we're going to close, cover up all of this. And let's look at the first one in row 3. So for this one, we have 8 and 2 ninths minus 4 and 5 ninths. So I'm going to take 5 ninths and I'm going to subtract it from 2 ninths. Can I do that? No, because 2 is smaller than 5. How can I subtract more than I already have, right? So I will have to borrow. So my 8 is going to become a 7. I'm still borrowing my 1. I'm bringing my 1 over. But I'm going to rename it. What should I rename it? 9 ninths would make a lot of sense because the bottom number is a 9, right? So 9 ninths, same thing as 1. However, here's my issue. I now have 9 ninths that has to go here, but I still have a 2 ninths here. I can't just forget about the fact that there's already a fraction there. So what I have to do then is I have to add the 2 ninths plus the 9 ninths. Okay? So 2 ninths plus 9 ninths is 11 ninths, right? So my new number then is 11 ninths. And I'm going to subtract that from 5 ninths. Ignore the numbers underneath that I'm writing over. So 11 ninths minus 5 ninths. That'll give me 11 minus 5. That will give me 6 ninths, right? And then I have to look at my whole numbers. Don't forget I got them over here yet. 7 minus 4 is 3. So 3 and 6 ninths. But am I finished? No, because I have to reduce the fraction part. So I'm going to divide the top and the bottom by what number? 3. Yes. So divide top and bottom by 3. And that gives me 6 divided by 3 is 2. 9 divided by 3 is 3. So my final answer then is, in blue, 3 and 2/3. So that's borrowing with fractions. I think we'll do one more that way. Let's try this one right here. Let's try this one. 14 and 7/12 minus 6 and 11/12. Well, okay. I know that I cannot take 11 from 7 because 11 is more than 7. So I have to borrow. So 14 becomes a 13. And I'm bringing 1 over. But I'm going to rewrite my 1 as 12 over 12. But I've already got a fraction there. I've got a 7/12 there. And I have to add 12/12 to it. So what am I going to end up with? I'm going to end up with 12 and 7 more, 19, right? 19/12. 19/12. And I'm going to subtract 11/12 from that. And that will give me 19 minus 11. 9 minus 1 is 8. 1 minus 1 is 0, so 8. And then my bottom number is 12. And now I subtract my whole numbers. A 13 minus a 6 will be 7. But now I have to reduce, so I'm going to divide the top and the bottom by, what do you think? 4. So divide by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So my final answer is 7 and 2/3. So that's the final answer. So that's borrowing with fractions. Okay, I'll give you a minute and pause if you need to. I'm going to clear drawings. Okay, clear my drawings. Let's go on to try, let's see if we get in. Okay, let's try row 6 because now we have different denominators, right? So let's put a little box here. Take that away for us. Okay, so let's do the middle one right here. Let's do that. So I see that my bottoms and denominators are not the same, so I have to get them the same first. So let's, oops, it's the wrong color. Let's get them the same. So 1/6 and 1/3, we could probably keep this as 6, couldn't we? Yes, we could. 1/6, and then 2/3 though, however, we have to change that into 6. So that will become 3 times what gives me 6? 2. So 2 times 2 is 4. So now I'm at the borrowing situation because 4 is bigger than 1. So I have to go over to the 15 and borrow and make that a 14. So now I'm borrowing 1, and I'm going to bring my 1 over, but I'm not going to call it a 1. I'm going to change it over to 6/6. And that 6/6 is going to be added to the 1/6 that's already there. So my new subtracting number is going to be 7/6, because 6 plus 1 is 7. And my bottom number is going to be still 4/6 here. And now I can subtract. 7/6 minus 4/6 is going to give me 3/6. Be a 3. 3/6. And I subtract my whole numbers. 14 minus 3, 11. And 3/6. However, I'm still not done. I can reduce 3/6. An extra little line in there. I'll just leave it. So it becomes 11, and I'm sure you can tell 3/6 when you reduce it is 11 and 1/2. Yeah. So the final answer to that is 11 and 1/2. Okay. So give those a try at home. See if you can get all the answers correct. Let's go on from there. This was the next page I want to do is 37. These are more of the same, just write them vertically. So if we go on from there, let's try some word problems. I'm going to try number 3. So word problems can be a stumper. So let's see what we got going on here. So let's get rid of all the others and just have 3 in front of us here. So number 3 says, before leaving on a weekend trip, Mr. Green noticed that his mileage gauge registered 20,245 miles and 3/10. When he returned home, the gauge registered 20,734 and 7/10. Excuse me. So it went up. And that would be making common sense because if you drive a car, mileage is going to go up. How many miles did Mr. Green drive that weekend? So is this going to be an adding or a subtracting problem? Correct. This is going to be a subtracting problem. So we are going to rewrite that. So the bigger number is going to go on top because that's the ending mileage. So the bigger number is 20,734 and 7/10. 7/10. And I'm going to subtract 20,245. And how many tenths? 3/10 a mile. And I'm going to subtract. So, subtraction here. So first I subtract my fractions, and lucky me, the bottom numbers are the same, so I don't have to go about changing all that. So I just take 7/10 minus 3/10. Right, 4/10. And then I subtract the whole number. Can't take a 5 from a 4, so you have to borrow from the 3 and make it a 2. The 4 becomes a 14. 14 from 5, 9. 2 from 4 you can't do, so you borrow from the 7 and make it a 6. This becomes 12. 12 minus 4 is 8. 6 minus 2 is 4. 0 minus 0 is 0, and 2 minus 2 is 0. So am I done? No, I still need to reduce the 4/10. So I can divide the top and the bottom by 2. And I'm going to put my answer in a different spot because I ran out of screen space here. So the total answer then is 489. How many miles did he drive that weekend? He drove 489 and 2/5 miles, right? So that's the answer to word problem number 3. I want to do just 2 more, number 13 and number 14. And again, a good way to learn is to pause the video, try them first, and then watch me do them and see if you got them right. If you want to do that, feel free to do that. Number 13. Well, first you got to read what's above it. A town needs $3 million for a new recreation center. So far, the town has received 3/4 of a million from private gifts, 1 1/8 million from a state grant, and $500,000 from a federal grant. What total amount has the town received so far? Adding or subtracting? That is going to be adding. We have to add what they've gotten so far. So far, they've gotten 3/4 of a million. They've gotten 1 1/8 of a million. And they've gotten $500,000. Put all those together and add those up. Now we have no numbers on the bottom that are the same. So we have to first change every one of the fractions to have the same bottom number. So I see that 8 is going to work for all the numbers because 2 will go into 8, 4 will go into 8, and 8 can just stay 8, right? So this will just stay 1/8. Just rewrite that over here. Now, 4 times what gives me 8? 2. So times 2 on the top. 2 times 3 is 6/8. 2 times what gives me 8 on the bottom? 4. 4 times 1 is 4. 4/8. Now I add all those up. 6 plus 1 is 7. 7 plus 4 is 11. 11/8. Oh, this is a real good one because guess what? 11/8. And then we add our whole numbers. We have a 1. But now look what happened. We came up with 11 on the top and 8 on the bottom. Well, the top number now is bigger than the bottom number, so our fraction is improper. So we have to change it over to a mixed number. So 11/8 is the same as, and I'm going to change colors here just to show you, it's the same as dividing 11 in the inside, top number in the inside, bottom number in the outside. How many 8s go into 11? Well, only one. 8 times 1 is 8. And you could probably start doing this in your head too. 11 minus 8 is 3. So that 3 is my remainder. That comes back up to the top and becomes the numerator of my fraction. And 8 stays the denominator. Now, this 1 3/8 is the rewritten number of 11/8. Notice how I have a 1 and a 1, right? So I have to combine my two whole numbers now. So 1 plus 1 becomes 2. So the total amount is going to be 2. And what fractional part is left? 3/8, right? So the total amount the town has received so far is 2 3/8. How much more money does the town need to reach its goal? What are you going to do here? Add or subtract? Subtract, right. So we have a total needed of 3 million. So I'm going to erase some of these guys here so that we can go on to the next problem with a little bit of space here. Okay, so we have to subtract the 3 million minus what we've collected so far, 2 3/8. We figured out in problem number 13. And now we subtract. You can't take 2 or 3/8 from 3 or from nothing. So you got to borrow from the 3, and that becomes a 2. This becomes 8/8. There's nothing to add to it because it's an empty space, so we don't have to figure out that. We just can add 8/8. 8 minus 3 is 5/8. And then 2 minus 2 is 0, right? So how much money does the town need to reach its goal? 5/8 of a million. Put a dollar sign there. It's supposed to be a dollar sign. 5/8 of a million. So 5/8 of a million. Okay, so give those word problems a try. I'm going to clear my drawings here. And I believe we are at the end of the packet, so I'm going to come back and let's take a look for a second. Were you able to understand all of these objectives? Can you now subtract fractions with the same denominators with different denominators? Can you subtract mixed numbers? Can you borrow with subtraction? And can you apply your subtraction skills to word problems? So my answer to that would be yes, and I wish you luck on your studying of this packet. So come back to you here. Oops. Have a great day. Bye.